Hello, everybody. As Saulis said, my presentation is ArcGIS for efficient monitoring of cultural heritage objects, new quality, sustainability, and scalability. In this presentation, I share some achievements of our organization. I will briefly talk about monitoring of cultural heritage objects in Lithuania. What is the importance and significance of this function? I will present what kind of problems we encountered when we didn't use technologies to monitor cultural heritage objects. And I will also present a platform for monitoring cultural heritage objects based on GIS technologies, which has been successfully operating in our organization since this year's March. The Department of Cultural Heritage, among many other functions, monitors movable and immovable cultural heritage objects in Lithuania. Cultural heritage monitoring includes periodic observation and recording of objects' condition, fixation, assessment, generalization, and forecasting of the influence, destroying or damaging valuable properties. The legislation of Lithuania says the department must inspect the cultural heritage objects at least once every 5 years. There are almost 14,000 immovable cultural heritage objects and almost 8,000 movable cultural properties. So in general, there are about 22,000 heritage objects to be inspected within 5 years. Our specialists not only inspect the objects, but also fill in special forms. And every quarter and at the end of year, summarize and analyze how the condition of cultural heritage objects have changed, what are tendencies of change, what factors may negatively affect cultural heritage objects in the future. The Department of Cultural Heritage has 15 employees who take upon function of inspectors. They have to inspect about 180 movable cultural heritage objects and about 100 movable cultural properties per year, fill in necessary documentation, prepare reports of their activities. I will also try to answer the question on why we had to find new solution in the process of monitoring cultural heritage objects and why change were needed in this field. It all starts with the planning of inspection. As you can see in the first illustration above, every year a yearly inspection plan is made in high-volume Excel spreadsheet with several thousand objects which need to be inspected. The next step is implementation and inspection. Second illustration below shows what kind of paper form must be completed during the inspection of cultural heritage objects. After each quarter, inspector must summarize the results of their inspections. And at the end of year, the summary and analysis of inspection data begins. Each territorial division of the department submits reports, and then we have to combine the data into one single document according to which we could draw conclusions about change in the physical condition of the cultural heritage object inspected this year on a scale from 1 to 5 points. Also condition change tendencies, for example, how the condition of manors have changed since last year. Also to make a forecast of factors they may negatively or positively affect cultural heritage objects. From what you have heard, it is easy to identify why the process of monitoring cultural heritage objects is irrational and why it is necessary to use GIS technology. In summary, it is a complex assignment for cultural heritage inspection. These high-volume spreadsheets are hard to navigate, can include errors, and are not dynamic. Field inspections are inefficient. That includes paper forms, complicated editing and documentation formalities, manual data processing. And the generalization and analysis or presentation of the collected information to specialists and the public is complicated. After identifying mentioned deficiency in the process of monitoring cultural heritage objects, we set the goal to make the process simple and smooth. So it is necessary to facilitate cultural heritage inspection assignments, optimize field inspection, and provide real-time status updates and results. So I will discuss how we achieve each of the tasks. Now, instead of annual inspection plan, when tasks are difficult to change and update, for cultural heritage inspection, we use simple web application. Task assignment application was made with Web App Builder for ArcGIS, which allows to create application without any coding required. In this image, you can see what application looks like. We use of cultural heritage objects layer from Register of Cultural Property. To make the task assignment tool easier to use, instructions are provided on the right side of the application, so the user doesn't need to open any additional manuals. On the left side, we have predefined suggestive filters that helps to narrow down cultural heritage objects for selection. We can filter out cultural heritage objects by county, by their significance, and most importantly, by the status of the tasks. We can see how many tasks have been assigned, how many have been complete, and how many are still waited to be completed. Task status are color-coded on the application map. Green, objects that still needs to be inspected. Yellows, objects that have been already inspected, and so on. Assignment of the task can be done in two ways. The one provides full editing capabilities. You can choose cultural heritage objects and change the status of the task, and choose field worker who implement inspection. This tool can be used to change other important information about cultural heritage objects, but more useful is group assignment, where you can select multiple cultural heritage objects in a map or by list, and simple type field worker name and change status to assign. And that's it. An easy way to plan an inspection. As soon as the status of tasks is changed in web application, they also change in the mobile application of field workers, and the workers only see the tasks assigned to them. So let's move on that part. Task implementation is a cycle that consists of following steps. First is tasks and information about cultural heritage objects are automatically transferred from web application to mobile application ArcGIS for Explorer, where workers can review tasks and select the ones which they will inspect. Field workers see the assigned task on the map of the mobile application Explorer, and by selecting the object to be inspected, all the necessary information is transferred to another application, Survey 123. Survey is an application where workers fill out inspection form, so then transfer data and additional data that has gathered during the inspection moves into Integromat, which is used to make inspection form and automatically sent to the field worker email. Integromat closes the cycle and updates a feature layer of cultural heritage objects. And in Web Tasks Assignment application, the objects are marked as complete, the icon turns yellow, and collected data goes to Results dashboard. I will briefly talk about each part of the cycle and shows how it improves and speeds up task performance. When field worker initiates an inspection, the information about cultural heritage objects collected in Explorer application layer and required to be entered into inspection form is automatically transferred to the Survey 123. It is no longer necessary to enter information about cultural heritage object, its unique number, name, address, information about employee himself, like name, position, and about previous inspection, etc. So when field workers click button Start Inspection, he is redirected to application Survey, which is used to collect information about cultural heritage objects condition change. The form of the inspection in this application was designed with as few questions as possible. All data that have been transferred from Explorer, it's not shown here, but it will appear in the final report form. Developing this platform, we also get Spike devices, which is integrated into Survey application. Spike measures height, width, length, areas, and target location. So you just take photos, and Spike shows measurements you need. This laser measuring tool is very useful for detecting damage or deformation of cultural heritage building. To identify changes or damage to the archaeological heritage site, in Survey application, we have configured GPS-based tool. With this tool, inspector can draw up a damage scheme just by walking at the site of the damage. These tools are very important for capturing primary damage to heritage objects and acts as verifiable record. After the inspection, when we send out a survey form, inspection reports are generated automatically and sent to the field worker mailboxes. Inspection reports are designed to look identical to paper forms and in accordance with legal requirements. It can also include the picture taken with spike or without and signed with qualified electronic signature. The final part of my presentation is result reviewing. In this illustration, you see the ArcGIS dashboard, or the tool for summarizing inspection results. This tool will radically change the so far complicated generalization results of cultural heritage monitoring, eliminate previously inaccuracies and human errors. Now we do not need to wait for field workers to prepare their annual inspection reports in high-volume spreadsheets. Now we can see the information about inspection change instantly in real time. In this dashboard, it is possible to compare different inspection periods, filtered information according to various characteristics, like status of object, condition change, and see the objects that are most affected. With this tool, for analyzing the condition of cultural heritage objects, we can ensure the rationality of state management and the development of programs for heritage maintenance and other protection programs. Also, this information will be easy to export for accessible formats and share it with professionals and the public. So, to conclude, we have greatly improved in the process of monitoring cultural heritage objects. With the help of mobile apps, we have digitized and faster cultural heritage objects monitoring. No more large Excel spreadsheets for task assignment. Tasks are assigned directly to the field workers. Paperless process of cultural heritage monitoring. We are completely eliminating paper documents in this process. Spike and survey provide precise measures of inspected heritage objects. And we have instant reports and real-time result dashboard. Also, inspection results are stored on ArcGIS Online, so historical data can be used later on, and Survey 123 allows to collect additional information for further analysis that was not used in survey. So in general, we made process of cultural heritage object monitoring simple and smooth. So thank you for your attention, and I want to also thank my colleagues who works on this project. Thank you.